Um, and so we basically want to make sure that our advice is really applicable to anybody, even if you're not a computer science major, and even if you haven't worked in AI that much. We're hoping that this Building a Career in AI series can be valuable and helpful for you no matter what. So a quick roadmap for this particular workshop and what we're going to go over. We're first going to kind of go over a kind of overall strategy and philosophy that you might want to think about when you're thinking about picking classes. And then we'll go a bit more into specifics about lower div, upper division, and graduate level courses that you might be interested in taking and how you might want to think about prioritizing those classes. And then after that, we'll talk briefly about different careers that you might want to go into with artificial intelligence. And after that, we're going to talk a little bit about examples of tools that you might want to use for doing class scheduling, for building a career in AI. And then finally, at the end, we'll be using breakout rooms in Zoom so that you guys can have some one-on-one interaction with us officers. If you have any questions about what classes you might want to take or need any advice, then we'll be there happy to answer your questions as long as you need. And that's the plan for today. So let's go over a little overall strategy about what you should think about when kind of talking about classes you might want to take if you want to build a career in AI. But before that, first, we'd kind of like to get an idea of what kind of audience we have here and what you guys are interested. So here I'm launching a poll just to see, we're just kind of trying to gauge what kind of topics in machine learning you guys are interested in, and what maybe are interesting things you might want to work on. Just please answer the poll and we'll get on with this pretty quickly. Hopefully you guys are interested in a lot of different things because I think we have a pretty diverse audience. All right, awesome. So it seems like you guys are really interested in pretty much all of the things across the board, from machine learning research, doing applied machine learning, data science, computer vision, natural language processing, all across the board. So that's really cool. And so a lot of the things we're going to cover in our workshop today are going to dive into a lot of those interests, and we're going to recommend some courses for you guys to take if you're interested in these specific things. So really awesome. So just some overall things you should think about when you're trying to build a path onto a career in AI. So you kind of have to start with your foundations, doing courses, coming to ACM AI workshops to learn about things, doing personal projects and taking maybe supplemental online classes. Foundation that you might want to build in order to actually gain experience by doing things in research labs or doing things in internships in industry. And all of these things will help you once you graduate or once you go to grad school, pursue your career in AI, whether it be doing machine learning engineering at a company, or maybe doing a PhD or master's at another school. This is the kind of framework that we want to think about in terms of picking our classes. So how do you really optimize your coursework if you want to get internships that will help you actually advance your career? So as you guys all know, internships generally happen while you're a student at UCLA. So maybe during the summer, after your sophomore or junior, or maybe even freshman year. If you want to be able to do this, then you ideally would want to have the right coursework and background in order to do this. And if you're a computer science major, for example, the most common path for a lot of people is to follow the provided and recommended course scheduling that like the computer science department provides you, or if you're a different major, it might be to follow that department's requirements. And a lot of the times they have these example course schedules that will get you on track to graduate in 4 years, for example. But what we're telling you is, generally speaking, for a lot of these course schedules, they push a lot of the electives for your major requirements towards the end, oftentimes during senior year of your time at UCLA. And so why is this a problem if you want to build a career in AI? So a lot of the times, If you don't have a lot of the right coursework, it's really difficult to actually get interviews and get research positions at UCLA or at another big company outside. So it's advantageous in order to try to push some of these electives a bit earlier in your career while you're at UCLA. And the reason this is important for artificial intelligence courses is because the majority of artificial intelligence and machine learning courses are categorized or would be categorized as electives for the vast majority of majors, even computer science majors. There are no specific requirements for you to actually take artificial intelligence or machine learning classes in order to graduate. And so if you are interested in actually um, getting an internship that actually uses the knowledge you learn in a machine learning and artificial intelligence course, it's highly beneficial for you to maybe rearrange your schedule a little bit in order to move these classes towards maybe your first, second, or third year of your time at UCLA, so that you actually have time to apply this knowledge at an internship or research position. And so our general recommendation with the classes that we're going to talk about today is that you take them at the earliest convenience that makes sense for you, that doesn't throw you off track to graduate. And so this will allow you to maybe say, well, if I'm planning to apply to an internship maybe next fall, then I can think about what kind of classes I need to take now in order to be ready then if I want to do machine learning for an internship I'm applying at that time. So yeah, as we stated before, course planning is really should be kind of thought as a tool for you to actually break into data science or computer vision or medical imaging, whatever subfield or application domain of artificial intelligence you're interested in. And this will enable you to get a leg up on a lot of internships and research positions. So just we're going to quickly go over a lot of course recommendations for lower div, upper div, and graduate level courses. So as you expected, pretty much this is the standard recommendation for anyone who's coming to UCLA as like a STEM major. You should do the technical courses, the math courses that are recommended for you. So in this case, for machine learning, the most important things that you should really be focused on are the Math 30 series and the CS 30 series. If you're a computer science major, you're probably doing this already. And it's very likely that if you're also another related STEM major, you're probably doing the same math courses as well. And so the way I would think about this is that the most important things in computer science for machine learning are just the really fundamental things. So like CS 31 and 32. A lot of the more advanced things that might come in more advanced computer science classes aren't necessarily as important. And the same thing applies for math. So the most important things for machine learning for the most part are your multivariate calculus and your linear algebra classes. So our general recommendation at ACM AI, if you want to optimize your career or optimize your courses in order to maybe break into AI, is that once you've taken these core CS 31, 32, and Math 32A and B and Math 33A courses, you should begin to think about and look into taking the next courses that we would recommend in order to get the foundational knowledge as fast as possible. So the upper division courses here are really ones that are going to build the foundation that you need for pretty much any machine learning job. And so one thing that a lot of people are wondering about, because if you look at the most machine learning classes at UCLA, they'll list a probability course as a prerequisite. The simple reason for this is that probability is a very important piece of math that you need to know in order to really understand machine learning and apply this in the real world. And so a lot of people ask, what's the difference between maybe taking Math 170A or Stats 100A, or maybe the other probability courses in the electrical engineering or say civil engineering department? And so our general recommendation is if you want to do theoretical research or interested in theory, then it'd be advantageous for you to take Math 170A. And this is just because there's a lot more emphasis on doing proofs in Math 170A. But otherwise, if you're mostly just interested in doing application level stuff for artificial intelligence, a lot of the times taking the other usually easier probability courses is actually probably just fine. and will give you sufficient background in order to take the upper division machine learning classes that we're going to recommend to you later on. And furthermore, just while we're on the topic of upper div math courses, if you are one of those people who are interested in doing more theoretical machine learning research, it would be helpful if you took even more higher level probability courses, such as the Stats 100B and C series, or taking Math 170B, which is the successor course to Math 170A. And maybe taking more advanced linear algebra classes, Math 115A, as well as Math 164, which is optimization. And all of these are really I would say only really worth taking if you want a really solid foundation in theory, but are no means necessary for you to do machine learning engineering or even applied machine learning research. This is kind of just things that are related, but not necessarily interesting. Yeah. So these are the upper division core classes in machine learning are where you'll build the bulk of your machine learning knowledge. And so there's three pretty much main courses that we'd recommend anyone to take if you're interested in doing stuff in AI. And these are CS 146, CS 145, and a new course that was actually just added this previous winter, electrical engineering 147, which is deep learning. So CS 146 is where you're going to learn a lot of your machine learning, like typical statistical machine learning classical algorithms. And CS 45 kind of goes into the non-statistical machine learning methods, more clustering methods. But a lot of those things are not actually covered in CS 146, but we personally at ACM I believe that a lot of those algorithms are really important. And so maybe you should take, like, for the most part, you should probably take CS 146 and 145. Those are like the two most important things. And if you're really interested in doing any kind of machine learning that's like cutting edge or state of the art right now, or even in industry, you guys have probably heard that deep learning is a pretty hot field now. And it's pretty rare, at least in industry, to do any machine learning or AI job without deep learning knowledge. So in other words, with only knowledge of things that you might get out of CS 146 or 145. So it would be highly recommended that you take electrical engineering 147, which is the deep learning course as well, in order to prepare you the best for a career in AI. A quick thing to note about EE 147 is that previously this was a graduate level course called EE 239 AS. This is the designation that the electrical engineering department uses to identify new experimental courses. So for the past 3 years, they were experimenting with this deep learning course, offering it once a year just in the winter. And they've gotten really good feedback and results from it. And so they've made this a permanent offering as EE 147/247. It's cross-listed as a graduate level course. And so it's kind of strange that a deep learning course would be in the electrical engineering department. And I think a lot of people aren't aware of this, but it is pretty important nowadays in order to actually learn deep learning, in order to apply machine learning to real world problems, because it's just used in a really wide variety of domains. Yeah. And anecdotally, I've taken EE 147, and a lot of other people have taken EE 147 as undergraduates as well. And most of them generally will tell you that although 146 is considered a soft prerequisite for EE 147, EE 147 is actually in many ways actually easier than CS 146. So for those of you who are worried about being in maybe a graduate level course, I would say if you found CS 146 to be fine, you'll probably find EE 147 to be easier. And another reason for this is that generally the professor separates the curves between the grad students and the undergraduates taking the course. So you're not going to be competing with graduate students in the course for your grade. So you should be fine either way. And we're also aware that a lot of people in our audience are not necessarily computer science majors. So it might be difficult in order to get enrolled in CS 146. It's quite a popular course amongst computer science majors, and especially when there's a really good professor who's teaching it, who's like highly rated on Bruin Walk. And so another recommendation we'd have is that If you can't get into CS 146, taking Math 156, this is the equivalent machine learning course in the mathematics department, should be also sufficient. It covers roughly the same amount of material and should give you a similar amount of preparation for machine learning. And so, yeah, if you take all three of these courses, we would say that you have a pretty good like foundation for going in and applying a lot of machine learning algorithms to real world problems for sure, and maybe landing even internships or research positions. Another question we actually get asked a lot is the difference between CS 146 and 145, and that's because there's some significant overlap between the content in both of those courses. So for instance, topics such as logistic regression, linear regression, and support vector machines are covered in both classes. However, there are some things that are unique to both of those classes. So CS 146 has a lot more of the mathematics and theory behind machine learning, and is a lot more focused on statistical machine learning algorithms. On the other hand, CS 145 covers a lot of non-statistical machine learning methods and things such as graph mining, tree mining, and advanced clustering methods that CS 146 doesn't cover. And in addition, in terms of the structure of the course, typically CS 145 also has a course project where you might get some more hands-on experience on actually applying the algorithms you learn in class to a real world problem. So from our view, we would recommend that you take both. I would say that the overlapping content is actually quite small. They go through it quite quickly in both courses. And the bulk of the class, I would say, is pretty different. And both are pretty important for doing a lot of real world machine learning work. So we would recommend that you take both if you have time in your schedule, just as soon as possible so that you can move on to the other courses. And so there's some other artificial intelligence and machine learning courses that we would kind of classify under more of a specialty type course. And one of these is CS 161, Artificial Intelligence. And you guys might be surprised why we kind of classify this as more of a specialty course. And this is simply because a lot of the things that are taught in CS 161, at least right now, are not super relevant if you want to do a lot of cutting edge machine learning research or work in industry. A lot of the stuff is it covers a lot more classical AI stuff. It's also taught in Lisp, which is kind of an older programming language. So we would say that taking this course is not super necessary in order for you to actually do research or do a machine learning engineering job. Although there's a lot of really interesting classical AI topics. So if you were interested in research in artificial intelligence, like more theoretical research, we would highly recommend you take this as well. There's also some other courses that are really interesting in the computer science department, such as CS 168, which is medical imaging. In this class, the professor kind of goes over a lot of different machine learning techniques for doing things like detecting different diseases from, say, X-ray scans or things like that, and is also project-based. So if you're looking for something where you want to apply machine learning in a more application-focused area in biology, then this might be a good course for you. Similarly, CS 188 is focused on computer vision and also has a lot of interesting projects that you can do that apply the actual algorithms to computer vision problems. So if you're interested in computer vision, definitely look out for that. One thing to note is that this has only been offered once before, I think last fall, and it's a CS 188, which means it's an experimental CS course, which means they'll probably offer it again. And if you guys give it like really good feedback, then hopefully it becomes a permanent course. In addition, you can also get credit. So if you happen to join a research lab at UCLA that's doing machine learning research, a lot of the times you can actually get course credit for this that you can apply to an elective. And this is something we're going to discuss in our next workshop, where we'll talk about a bit more about doing AI research, internships, and doing work in industry. And another interesting upper division course that I think you might not have realized is there is Stats 115. It's a new statistics course in the statistics department taught by Professor Tao Gao. And that course kind of goes over how you can do really, really basic machine learning techniques in order to kind of build systems that make decisions on their own. If you've heard of reinforcement learning, this is kind of like a really lightweight introduction into reinforcement learning. So if you're interested in using machine learning in order to help agents make decisions or computers make decisions, then we would recommend this course for you. And finally, for our course overview, we're going to kind of go a little bit into graduate level courses. And we realized that the idea of taking graduate level courses during your undergraduate career can seem kind of intimidating for a lot of people. And we're here to tell you that actually it's not that bad. And in some cases, I think for a lot of you, it might be even preferable to taking some other CS electives. So why should you take graduate courses? So if you're a computer science major, typically you can get computer science elective credit for a lot of the courses that we've recommended. So for example, before deep learning was offered only as a graduate level course, EE 239 AS. But if you were a computer science major and you decided to take that class, then you could petition the computer science department to actually allow you to petition that as an elective. And another reason you might want to do this is because graduate level courses are typically actually a lot easier in terms of grading. A lot of graduate courses have no exams. They have like group projects instead. And a lot of the times it's just a lot more chill environment. The professor is more inclined to give a lot of people A's a lot of the time because they realize a lot of graduate students are like really busy. They do research and doing all sorts of other different things. And this is just the kind of general vibe you get from a lot of graduate level courses. I actually took a graduate level course in natural language processing the previous quarter. And a student, a graduate student was actually asking the professor about some specifics about grading and stuff. And the professor said to him verbatim, "You should not worry about your grade in this class." And this was to a graduate level student. So this is kind of indicative of the attitude that a lot of professors who teach graduate level courses give. And I'm not saying that like all of them are like super easy, but typically they're a lot more laid back and chill. And maybe more importantly for a lot of you is that these graduate level courses go into some really interesting topics. And this is really where you can get really dive deep into a lot of these application fields like computer vision or natural language processing. Just simply because these courses aren't really offered at the undergraduate level at UCLA at the moment. And so you can get a lot of really interesting knowledge that you can apply to your job or internship whenever you do decide or do get into that. Another interesting thing to note is that, like many of you know, it's often a good idea to list coursework that you've taken on your resume whenever you're applying to a job. And so if you list that you've taken a graduate level course, especially in AI, it actually looks pretty good and makes you a lot more competitive with graduate level students. This is something we're going to talk a little bit about in our next workshop series. But for a lot of machine learning internship or research position jobs, a lot of the times companies and labs will prefer to take graduate level students, so masters or PhDs and above. And so if you really think about, what's the difference between a master's and an undergraduate, the only real difference is that the master's student has taken graduate level courses in artificial intelligence. So if you have these courses like in your pocket, maybe on your resume, you'll a lot of the times like look kind of a lot more on par with at least a master's student, which can give you a really huge leg up when you're trying to apply to these internships or labs for your jobs. And so another question, a lot of the times once I've convinced people that taking graduate level courses is maybe a good idea, how do you even pick what graduate courses you can take and how do you even get into these courses? So our general advice for you guys for taking graduate level courses is to basically just do whatever is really interesting to you. And 99% of the time, the professor who's teaching it will be a leading expert in the field. And so we're pretty fortunate to be at UCLA, where there's a lot of really interesting cutting edge machine learning and AI research going on right now. And most of the time, these professors are teaching the course because they want to find students who are interested in the field. And so a lot of the times they'll actually be really invested in these course projects and really invested in their students, and will definitely know a lot about these topics. So for me, I think the most important thing is just to pick the courses based on your interests. So another thing about how you can actually enroll in these classes. So generally speaking, for graduate level courses, you won't be able to directly enroll through MyUCLA. Um, and typically you would need to obtain a PTE number or permission to enroll number from the professor. And so basically you just want to send an email to the professor, and 99% of the time the professor will just give you a PTE. As long as you kind of just say you're interested, it doesn't have to be super long or anything. I've never heard of any situation where a professor did not give an undergraduate a PTE when the undergraduate wanted to enroll in the graduate level course. Generally speaking, professors are pretty interested in people who are interested in their research, and will welcome you whether you're an undergraduate or graduate level students. So a couple of course recommendations for graduate level courses based on different interests. So if you're interested in doing more advanced machine learning stuff, it might be advisable to take CS260, 276, or 247. These are the advanced equivalents of 146, 145, and 140 EE 147 that we discussed earlier in our upper division section. But our general recommendation is that if you've already taken those courses in the lower division equivalents, you probably shouldn't take these courses, just simply because there's a lot of overlap, and your time would honestly probably better be spent taking a graduate level course in a more specific subdomain that you're interested in. It's something that will probably have a lot more benefit for you as a person, and for getting into any particular job that you're interested in. If you're someone who's really interested in artificial intelligence research, something I would highly recommend is taking CS 269 during a quarter when there's a professor teaching a topic that's interesting to you. So the way this class works is that every single quarter, it's a different professor and a different topic. So if you look on the course planner, when you're enrolling for classes, it will list the professor teaching it. And CS 269 will be about whatever that professor's research topic is. So for example, last quarter in winter, I took CS 269 and it was taught by Professor Kai-Wei Chang. And the research or the topic of the course was about fairness, accountability, transparency, and ethics in natural language processing research. And so he does research in this field and knew a lot about the field. And it was just a really cool way in order to get to know the professor well. It's typically a smaller class, and it's project-based. There were no exams. And it's a really good way to just get to know other graduate students and the professors doing research in a particular area you're interested in. So if you're interested in doing AI research, I would highly recommend that if you see a professor when you're enrolling for classes that's doing research you're really interested in or wants to get involved in, just shoot the professor an email and maybe ask to enroll in this class, because it's a really good way in order to do it. And the grading is pretty easy. Everyone, at least when I took it last quarter, everyone got an A. That's actually the professor who said you shouldn't worry about your grade in this class. And so it's probably even easier than taking a lot of other electives that you might take. And at the same time, it builds your career. It looks good because you can say you took a graduate level natural language processing course. And also, if you're actually interested in the topic, it's it's a lot of fun to actually do the projects as well. If you're interested in computer vision, there is a 3-course series on statistical modeling and learning in vision. That's CS 266 ABC. And it's also cross-listed in the statistics department as Stats 232 A, B, and C. This is taught by Professor Song-Chun Zhu, and he's one of the leading computer vision researchers in the world right now. He's currently a professor at UCLA, leading the VCLA lab. So if you're interested in computer vision, definitely look into this course. If you're interested in natural language processing, Professor Kai-Wei Chang, I mentioned earlier, leads the UCLA Natural Language Processing Lab. And so if you're interested in natural language processing, some quarters he teaches CS 263. And as I mentioned earlier, he also teaches 269, which is the NLP research seminar during select quarters. So if you're interested in natural language processing, definitely take a look at that. If you're a person who's interested in computational biology or applying machine learning to biological problems, there's interesting courses such as CS 226 and 229, which kind of go over computational biology and different methods in machine learning that can be applied to biological problems taught by Professor Sankara Raman. And he leads the machine learning and genomics lab. It's a pretty big lab in terms of their research output. So definitely really interesting stuff. And if you're interested, if you want even more like knowledge of computational biology, you can also take CS 222, which is algorithms in bioinformatics. And we'll go over a lot more of these classes, more so in our breakout session. We also have built like kind of like a course template type thing that can kind of guide you based on your specific interest, that has more stuff than what's presented on these slides here today. And so just one last thing to mention, when you're maybe planning for courses or when it's time to enroll in courses and you're looking at the class planner. So these are some things to maybe look out for. So CS 188 is one example of one of these courses. So every quarter in the computer science department, they do an experimental course that you can take usually, and you'll be able to generally get elective credit for most of these. And these, a lot of the times, these will cover a lot of advanced machine learning topics, and they're trying to just do a trial to see if this will work in an undergraduate setting. So for instance, computer vision was a course that was given as a CS 188 this past fall. And previously, CS 168 was actually tested as a CS 188 course. That was a course that went over medical imaging and then became a real course that was offered not just like every now and then, is offered regularly. The equivalent to this in the electrical engineering department is EE 239 AS. And this is where the deep learning course came from, which is now also an undergraduate deep learning course. And actually right now, a really interesting reinforcement learning class is being taught under the EE 239 AS title. And similarly, like I mentioned before, CS 269 also changes every quarter. So when you're looking for classes, if you're interested in research, definitely look out for that as well. So these are just 3 things that you might want to look out for when you're planning for classes. Now I will pass it over to Nisha to talk about careers in AI.
All right, cool. So let's say you guys take these courses, you really like AI, and you decide to pursue a career in it. We're going to talk a little bit about what that world of AI after graduation might look like. So to start, we're just going to talk about a few of the many companies that are doing like groundbreaking things in AI. So the first one is OpenAI. And OpenAI is like a research organization that's especially focused on creating AI like for social good and for the benefit of humanity. So if you find that you're really interested in AI as an undergrad, this might be somewhere that you'll end up in the future. Next is Google. And I'm sure you guys have all heard about the awesome AI projects that Google is working on. But today we wanted to talk about one specific one, which is Google's DeepMind collaboration with Google Health. So basically, they're working to detect cancer using AI. And so if you're interested in both health and AI, this is a really cool intersection that actually has the potential to save lives. Next is NVIDIA, which is another really big player in the AI world. And so they're working on a bunch of cool projects with self-driving cars. They also create AI software that basically helps businesses run more effectively. So they're another really cool one that you should definitely keep up with. We also have Facebook. And so this is another one that's been in the news a lot, Facebook using NLP to detect hate speech and basically try to curb fake news. So that's a really interesting application if you are interested in NLP. Next, we have Microsoft, which has invested in a ton of projects with AI in healthcare or AI in robotics. But something else that's really cool that Microsoft is doing is stuff with AI in ethics. So if you're interested in what AI should do rather than just what AI can do, it's definitely worth checking out Microsoft's ethical principles because they definitely have put in a lot of work in that area. Next, we have Baidu, which is a company that's based in China, actually. And they are one of the leaders in computer vision. So whether it's facial recognition or self-driving cars, if you're interested in computer vision, you should keep up with them as well. And then the last one that we're going to talk about today is Salesforce. And so Salesforce created this project called Salesforce Einstein, which basically works with businesses to create plans for them to like improve their marketing and overall run more efficiently. So again, if you're interested in the intersection of business and AI, that's something that you should definitely check out and read more about. So next we're going to talk about if you do end up at one of these companies, what you might be doing. And one of the things that I really love about AI is that there are so many different ways you can apply it. There are so many potential career paths. So these are just 3 of the most common ones that we thought were worth talking about today. So the first one is data scientist. And so if you work as a data scientist, you're basically going to be gathering and analyzing data sets and then helping organizations draw conclusions from that data. And so you're going to need a background in computer science, stats, and math. Another really common course is research. And so if you're a research scientist, you would work on developing and implementing new algorithms that address challenges in ML, NLP, basically any subset of AI. And a lot of your time will be spent reading and discussing any new literature that comes out in the field. And then the last one is ML engineer. So ML engineers are the ones who are actually developing, training, testing, and optimizing programs and models that do machine learning, so that learn from experience. And if you're an ML engineer, you definitely need to have mastered probably multiple programming languages. So now I'm going to turn it over to Vaishnavi, who's going to talk about what you can do starting from today to maybe get to those careers in the future.
Hi, so a lot of what we talked about today is really important information to keep in mind for when you're planning your courses in the future, or like potential careers you'd be going into. But something all of you should be doing right now, or should start doing right now, is to be reading in general about like articles and research papers that are coming out about latest news in the field of AI. Not just so that you could understand like the academic point of it, like new algorithms that are being developed, but also so you have a feel for how these new developments are being framed, right? So like if you see the article in the bottom left corner, it's titled AI Trends to Watch Out For. But someone else could be talking about the exact same content, but phrasing it differently, like AI trends to be excited about. So when you're going to this field, taking all these courses, it is really important to keep in mind how they're being applied in the real world and what the discussion is around these topics as well. So in the next slide, we have some links to important AI newsletters that you could be subscribing to. These are just 4 of them. John, can you go to the next slide? Thank you. So these are just 4 of them, but if you just Google AI newsletter or AI podcast, there's so many different ways you could be keeping up with the latest news. And that's something that we think is really important. Also, in a lot of courses you're taking, everyone comes in with different levels of experience, right? And sometimes that can be really intimidating too. So one way you can kind of level the playing field or be able to have important conversations about AI with all these people that share your enthusiasm is to be keeping up with the latest news. Like just right now, there's so many articles being released on how AI is helping like trace COVID and how we can use AI to like speed up the process of developing vaccines. So if you're keeping up with all this news, that's something that you could use in a conversation with like your colleagues, like in the future during classes or with professors. So if that's something you're not already doing right now, like we highly recommend you start doing that. Now we're handing it over to Justin to actually get into the course planning.
Hi guys, so just backtracking to the course planning, I'm just gonna run through a couple of resources for you guys. So I'm gonna go ahead and share screen. Let me know if this goes through as well. Okay.
Looks good, yeah.
Awesome. Okay, so we're going to link this in chat. This is a course template that we kind of made. I'm going to be walking through a couple of the references we have here. So first, we're going to look at our course curriculum. So this is specifically for computer science, but for those of you that this doesn't pertain to, just hold on for a second. So this is just kind of like an overview of what we can expect. Like this is a sample from CS, just like going through how to fulfill your degree requirement. And after that, we're going to look into the requisite tree. So again, this is for CS specifically, but this can kind of give you a general overview of what sort of classes we should be targeting in order to get to the ones that fit your desired interest. And these will all be linked again. This is another very helpful site that I found. So this is like a course description page. So you can actually look up and search through every single program within UCLA. Maybe most relevant for us would be in CS. So going there, it has like a list of all of the registrar courses split into like lower division. It even comes with like the units, and we can see like the prerequisites. So this is a really helpful resource to just kind of plan out things. And yeah, this is everything. This is our undergraduate study for computer science. So again, this is like another kind of detailing list that lists out everything that you need to do in order to meet your degree requirements. And another helpful thing to look into is the tentative course offerings. So this is something that is variable between academic years. So again, something that you should be checking for yourself as it pertains to you. But we can see the tentative course offerings for each quarter. This is something, again, you can use to help map out your career here at UCLA and hopefully within AI. So with that said, can I get one of the officers to actually plug in the course template in the chat? We're going to be transitioning into breakout rooms. So hopefully you guys are down for that.